Hello, everyone. Okay, we can get started for today's lecture. Thanks, everyone, for showing. And we have guests from Google as well who will be presenting Gemini Multimodal. So this lecture will be focused on reasoning across modalities. There have been a lot of releases starting December and even last year around. It's not enough to build agents just with text and text applications, text in, text out, math benchmarks, or coding benchmarks. It's quite valuable that these agents can go interact with real applications or web browser and so on. So, and of course, audio agents as well. A lot of focus of our class today will be on how do these models reason across vision and text, and we'll see quite a few examples and errors that exist. The applications that we built today are nowhere near robust, so all the releases that we have seen are closer to demo stage than being in production. Okay, logistics. So we have first homework assignment submitted. I see everyone submitted. How was it? Fun? Okay, at least one fun. Someone found it not fun? Want to give us a thumbs up? Okay. The second homework assignment is released. It's due in about 10 days. And what we would like you to understand is basically how when you build agents, you can actually use the self-improvement loop that we've been talking about to improve them. And you have a bonus part there where you get to build your own deep research agent. So start early and give us feedback if you are finding it too hard. Also, this one has a lot of LLM calls. So please use the smaller models. Don't exhaust all your credits on the homework. Ask questions. Yes. We don't expect you to go beyond $25 worth of usage just on OpenAI credits. GPT-4o. And you can use Gemini, which is free. Okay. And the CAs will have office hours. So ask questions ahead of time. It's one day after the February 17th holiday thing. So you should not expect answers on the last day. Okay, late policy, I think already all of you know, but if you haven't used your late days, you can use 2 late days per assignment. And if you use additional late day, there will be a 25% penalty. Project milestones. So project proposal feedbacks are already released. You've been assigned mentors. Please leverage the fact that you've been assigned mentors. And then we have a midterm project presentation coming up soon after the second homework is due. So I will post a schedule. We'll have a schedule up shortly. And please reach out and tell us if you need help getting to the midterm project presentation. We'll have a 5-minute presentation per group, almost something along those lines. So it's more a way for you to check in with us that you are making progress. And for the API credits, everyone should be credited. Everyone who emailed me was credited. For Gemini credits, if anyone wants to increase their credit limit for their project, please email us and we'll connect you. Okay. And office hours. So I will have office hours 4 to 4:30 p.m. today, and Azalia will have office hours Monday 12 to 1 p.m. And then John and Mert have their regular office hours. Any other requests? Okay, I'm not seeing any requests. So with that, we'll start. So this will be our schedule for today's lecture. We'll spend a considerable amount of time having the guest lecture from which will focus on the multimodal advances in Gemini. And Gemini 2.0 was released just this week. So we are very grateful that our industry partners could make it here. And then we will go through, of course, they can't share any details because it's a closed source model. So we will go through some open source works, including how GUI agents build their data sets to get visual grounding in place, and how Anthropic computer use has been benchmarked and what kind of errors people have seen as they have tried to benchmark these models. And of course, there is the OpenAI version, which is operator. We won't go through that one in detail. So with that, I will actually switch to the presentation on Gemini multimodal and have our guests over. Let me introduce them. So we have Melvin and Anirudh. Melvin actually graduated out of Stanford a decade ago. And so he's an alumni from Stanford, and we're very grateful he could make it here. Let's give him a round of applause for coming. And Anirudh is a product manager at Google on the multimodal side, and together they'll be giving us all the updates on what can we do with these latest models. Okay, let me switch the slide deck.
Yeah, it's good to be here, everyone. So I remember this class, I think, many years ago. This was when where I took 224D, which was Richard Socher's class on deep learning for NLP. Back then, I think, like, NLP, AI, we had a class on AI, we had machine learning, but that was the first deep learning class, I think, that stands for 224D. So it was quite back in 2014. So, yeah, so good to be back in the same room doing more deep learning. Yeah. So I think the way we'll do it, we have a bunch of slides. So Ani and I will just keep splitting. Yeah,
check this share screen is working. Yeah, it's working.
Okay. Ani, maybe come over here. Yeah. Oh, can you stay there? What is it?
If you want to be on the video, then you both should be.
Yes, exactly, because there's a video. Yeah. Yeah. Okay. Good. I think the other thing is, as Akansha was saying, we can't actually share much. We'll show you a lot of what Gemini does, and please feel free to ask the questions and interrupt us. It's very supposed to be very interactive. Okay, you go first.
Cool. Yeah. So first example, I think like reasoning is like flavor of the month. So we think it's a really cool example. Basically like a high level overview, and like we feed in with a toy image and a ball and a bunch of lines, which are like I guess surfaces, and our prompt is like which bucket would this ball fall into. The cool thing about this is it actually requires like visual reasoning. Right? The model needs to reason over pixels instead of just using visual information and then kind of performing its reasoning in text space. So yeah, give an example where the latest Gemini Pro version that was released on Wednesday yesterday. So gives you like a nice COT trace of each step.
All right.
Feel
So
free to chime in, by the way, if
Yeah,
you have
yeah,
any
yeah.
questions about like
or if you think
intuition for how the
yes.
model does these things.
More questions, yes. All right. Oh yeah, go ahead.
Version of Gemini was failing at this time?
Yeah, previous version of Gemini was failing,
Why was it failing?
yeah, I mean, these things are like hard to explain. I think there's something to be said about like the ability to kind of like tokenize the infinite image. So that's like a lot stronger now.
I was trying to get to that.
Yeah.
So like we have like a vision encoder, like OpenAI, for example, as their version of that. I think the open source standard is Siglet, so maybe yeah, you guys will see that later. I think that makes a big difference. Some of these things are also emergent, so it's hard to tell why someone would do better. I mean, this is an example that O1, O3 don't get. So yeah, it's like interesting why someone would get something. But this is like a very
Where's
cool
the screen? Yeah.
Okay, yeah, that's the speaker.
That's like my hypothesis, my personal.
No, how do I navigate that?
Yeah.
Maybe it's like, yeah, something in training. That's not another.
No, there was another hand. Yeah. Oh. Okay. Oh.
Fact that when these model, the reasoning capabilities don't emerge out of nowhere. So you guys have been learning how reasoning capabilities emerge. So maybe you will not get a very clear answer if you ask how Gemini 2.0 did it, but you guys know how you did it in math or in coding. So something similar has had to happen here for this to work.
I love this. The secrets we can't spill, Akansha spilling it. So,
Yeah,
it's great. Yeah. Question, yeah.
One is like interpreting the image itself,
Mhm.
and then given an image, how well do you reason about it?
Right.
So is the bottleneck like the difference main in converting the image into a format that the model can better understand, or is it actually that the format was the same as before, And it's the reasoning part that has to improve quite a bit.
Both, I think. So I think like one interesting thing is the like language models are not modality aware. So getting into details, but I think something that's interesting is like with Gemini, there's some improvement in like the vision encoder, so how we tokenize these images, so turn them into some embeddings that are like fed into the model. And then there's like maybe some like magic in the model itself, where the models like learn these capabilities. I don't know if that exactly answers your question. I think the like answer is like both, and we train end to end. So we
I
train
think-
the vision encoder
yeah.
with the LM, but yeah, Melvin.
No. I think the end-to-end part is key. Is that if you discretize these steps, then you're not sure what's happening at the boundary. But because it's trained end-to-end, you have vision understanding and you have generalization. You have a lot of reasoning happening in math and coding and text that generalizes into the multimodal reasoning, right?
Could you like now do some sort of application where you're using the new vision tokenizer with the old reasoning or the old vision tokenizer with the new reasoning?
Yeah, you could. I think.
But these folks will not be able to do it, unfortunately.
No, we'll try.
We can try, yeah.
We'll try.
I'm-
But roughly, I think everything moves forward. Like there's improvements on both, but the end-to-end part is key. That you model end-to-end, you don't discretize these steps. Yeah. All right, good engagement. Let's move on. So here, this one's another example. So you have like 3 of these cartons, and the prompt says transcribe this image into an HTML table of equal width. And you can see the HTML table, accurately transcribes all of the text. The 3 tables, they cannot still generate images, but even the logo, it's able to get that. It says twice as nice logo, with exactly the image in the, you see. So it's pretty cool where, previously LLMs would struggle with this, right? Like getting the orientation right. Yeah,
Is there explicit OCR model in here?
no, it's all native.
OpenAI will tell you sometimes, like my OCR model could pick up anything.
Oh, I
Yeah,
see. Yeah,
interesting.
I'm assuming
interesting.
that means, yeah.
So I think what OpenAI does is, and this is why Gemini is stronger, is like OpenAI, they like use an OCR model, take that text, feed that text in with the image, and that helps like the model then like understand text in that image. We like
Don't have
try
the
very
need
hard to
to.
not do that.
Yeah,
but, like,
and we don't have the need to actually,
we don't
because
need
the
to.
quality is pretty good. Happy with that. Yeah.
and
It seems like a prime case of potential test site contamination, though, I'm sure the LLMs have
Maybe.
seen some point how many
Yeah.
calories.
Sure.
maybe.
Yeah, sure.
It's
But
like-
it's this is specific to a brand, right? Like, so the whatever reading is, it's not going to be the same.
And we also didn't train with this like specific objective. Right? It's like not in training like image HTML in this form. So maybe this image is like on the web shares, so it's like
Hmm.
leaked in training.
You can try things like
Yeah, exactly.
skill.
Go to AI Studio.google.com, try a bunch of examples. Yeah. All right.
Yeah, so this is an example, training transcription. So yeah, this is something we care a lot about at Gemini because we like serve our models in search and in YouTube and in all these places, Android. So here's actually an example of like 3 models, and it kind of shows some of these like subtle errors. The 1.5 flash, like not so good. 2.0 flash, like gets the Chinese characters. We removed the red highlights in 4.0 out of whatever, but like again, like it gets the EP wrong, for example, or that's actually like a character. One of the interesting things that you get with VLMs is like world context and like parametric knowledge with OCR. So it actually gives you a response that's like in context of like broader knowledge, which is interesting. And like this and the previous example, like custom OCR models can't do, right? Like with the previous example, like existing OCR models can't preserve font style and structure and layout and so on. And here, like, I guess custom OCR modules don't have this like broader like world knowledge and kind of general capabilities that knowledge.
Yeah, good.
Is that like up to a certain point or is it live?
No,
Yeah, it's just up to a certain point.
up to the cutoff date, training
Yeah.
cutoff date. Yeah.
There are ways like so there's some tricks. Exactly,
Yes,
exactly. Yes, that's
you
what,
could.
yeah, that's what I was gonna mention is we have the ability to feed these images in through Google Lens. I don't know if you guys have used Lens ever. I used to work on that product, but basically that gives us like fresh retrieval of images from the web. So say you have an image of, I don't know, what's an example, like you're like at a Taylor Swift concert or something, you take an image, ask a question. With Gemini, it pulls similar images from the web and gives you fresh information. But that's that's like a tool, that's right? It's not in the core model.
All right, here's another example. So this one, actually, Ani, you talk about this.
Oh, sure, yeah. So, yeah, one capability, I guess, from like a product perspective that we saw like a lot of interest in was bounding boxes, object detection. Yeah, this is actually very cool how Gemini gets this. So on the left, Gemini will do 2D bounding box detection. On the right, 3D. There are like a lot of interesting applications in robotics. Is like the biggest place that we see this get used. I think maybe one piece of intuition is there are like a lot of existing models that do detection. So the question is like, why use Gemini? I think the interesting thing with Gemini is you can have the model like reason over the image and then detect things in the image. So for example, we have companies labeling their images using Gemini to train robots. And some of the questions they ask are like, detect the object in this image that's like blocking the movement path of this robot. And that's something that like existing detection models aren't able to do, but something that Gemini can do very well.
In this example, like for this balls as spheres, how does it know like which direct, like presumably that's not really well posed, right? The direction in which the cube is facing.
Yeah. So this is actually interesting. Like on AI Studio, if you guys have used AI Studio before, there's like a spatial understanding starter app, and you can tune like the tightness of this bounding box and like orientation. But yeah, that's a great question. And when you're trying to like superimpose a 3D bounding box on a 2D image, like yeah, you have like I guess one dimension of freedom basically.
Yeah, go ahead.
Camera parameters also for this, like
What do you mean by canonical camera parameter?
the camera intrinsics and extrinsics of purely for converting like an image into a 3D scene. You would need to know, like if you're assuming a pinhole model over here.
Yeah. I don't think we
I
do.
don't-
Yeah,
I don't
I
think
don't
we
think we
do,
do any of
yeah.
that. Whatever the LLM. Okay. Yeah.
But there's like nothing like in training, the model just sees like a bunch of these images with like human labeled or like custom detection model labeled 2D and 3D bounding boxes. So we don't use any like
Yeah.
yeah,
Additional
special-
parameters. Yeah. All right. Here's another one. So this one. Oh yeah. Go ahead.
Part of what led to this bounding box capability was some supervised fine tuning with human data and bounding boxes.
But that's sort of that's magnified by the VLM capability that you have in pre-training. So you need good image understanding to begin with to get to this stage. So both pre and post training.
Yeah, the intuition is maybe like in pre-training, the model learns kind of like core spatial understanding capabilities and orientation. And in post-training, we teach the model to like return coordinates in a specific format that we then use to draw these bounding boxes and so on. So yeah, it's like a bit of a
Okay, here's another example. So here you have a really long PDF that's uploaded. And then you ask a very specific question on who the Nobel Prize winners are and what the locations of these people are. Then Gemini can accurately, draw bounding boxes around it, extract the coordinates. And I think yesterday or a few days ago, when we launched Gemini 2.0, the first trending topic on Hacker News was PDF understanding of Gemini, right? Because we support long context, really long documents, 1 million tokens. You can upload multiple of these documents and you can reason through them and really do complex tasks. We have a few more examples of that. So again, composition on multiple axes, right? So there's understanding, there's spatial understanding, there's reasoning over text. There's also long context understanding or retrieval happening, and everything's happening end to end.
The other big reason that we care a lot about detection is computer use. So I think you like have a paper
Yeah.
on Anthropic's version of computer use, but that's like a big capability that we also care a lot about for detection. And that's a very similar form of like non-natural image detection where we want to be able to detect UI elements on screens, like text boxes for like keyword, like typing type things and so on. Yeah, so Melvin mentioned long contacts. It's like a very powerful capability. So Gemini, you can feed in like 1,000 pages with 1,000,000 token contacts, 2,000 pages with 2,000,000 with like efficient tokenization, you can do even more. But here's an example of like, I think an interesting like end-to-end task where the model, we basically fed in like 15 Google earnings reports, like 10 case 10 views, and then ask the model to basically pull information of like revenue numbers for various product areas, plot a chart with that information, reason over that chart, and then plot a second chart where the model compares numbers between earnings reports. So this is like an interesting example of something that's like, I think it gives us some hints of like what performing end-to-end tasks with these models and systems will look like. I think we're starting to see a bit of that with the reasoning models as well. And it's also something that we did with like a single prompt, zero shot. So in the past, we would have had to like chain a bunch of prompts to do this, maybe first with the vision component, then to generate code to plot the chart and so on. But here, like the model does this end-to-end with a single prompt.
All the use cases cherry picked in many ways. I mean, basically,
Yeah.
scenarios in one context where things in the middle get dropped and so
Right.
on.
Yeah.
Stress tested.
Yeah. So I think documents is like pretty good. Like video long context is a big issue, of course, with drop things and so on. Documents is actually very good. Like something I use the models for is this is being recorded, but like I don't know if you guys see the Doge tweets that come out like every day on like various things they're doing, and they link in like thousands of pages of PDFs. And if you want to fact check these things, like it's very easy now with these models, and like they don't miss these things. So
Yeah, I think documents
pretty
are
good.
pretty good. Yeah, I mean, another use case for me actually is, you know, we get training data from a lot of vendors, and most of this data comes in and out with spreadsheets. And what I actually do is I upload a lot of these spreadsheets onto Gemini and ask Gemini to find mistakes with the labeling that people have done, and it can categorize mistakes and things like that. So previously, you have to eyeball a whole bunch of things and aggregate. A lot of that is easier. Now you just have to eyeball the summary of Gemini, go and verify that.
Yeah, so your like homework assignments, you guys have to write paper summaries and stuff, like, yeah.
Go to Gemini, they're supposed to submit questions. I don't know if they're using it for
Yeah,
that, but they're
yeah.
definitely using audio reviews.
Oh, good.
I
Yes.
see. Yeah.
Yeah. That's pretty cool. Yeah.
Yeah, I remember writing these paper overviews. I mean, now like with AI Studio, by the way, for PDFs, you guys should go to AI Studio, because the latest models are on there and not Gemini.google.com. But yeah, you can like feed in long context documents for free and try these things out. And
Question here.
Yeah, you mentioned video long context. What are you
Yeah.
using to evaluate there?
Yeah, so we have a bunch of internal benchmarks that we use. So these are human evals in various use cases. We have some slides on this as well. And then there are like a bunch of external benchmarks, like video MME is a benchmark, ego schema, like ActivityNet. So there are like long video benchmarks externally, and exactly, yeah, are short. They're 5 minutes. Yeah, it's exactly.
Yeah.
It's hard though. It's a hard problem. Long video, but you know.
Your project is on video.
And I was co-author on a paper that uses, actually, we evaluate, I think, Gemini 1.5 on.
I see.
Cover long videos.
Okay.
Oh, nice, awesome. What was the eval called?
The papers, our video, it was narrows. So
Oh,
big-
awesome.
Bigger percentage.
Nice. Yeah, we should give you our emails. Like, I'd love to
Yeah, connect
more,
and
yeah.
yeah. figure
give you guys credits and stuff.
Yeah. Yeah.
Yeah.
Please.
Yeah.
Well, yeah,
Yeah.
for credits, yes.
Yeah, I think you have our emails.
Yeah. You should put it on the website or something. Yeah. Okay, here's another example, right? Web page transcription. Again, another example of you need to understand the page layout. You need to understand what's in each of the images of the titles, right? So the prompt goes, extract each of the books from this web page, return it as a JSON with these attributes, and then we produce a JSON of all of the books on the page. And if you don't do video understanding, it's hard to actually fathom some of these details and figure out the right thing.
Yeah. The
If
cool
you-
thing about this is like, if you, so with like existing approaches like Beautiful Soup and so on, like, the traditional web scraping approach is you like look at your HTML and then scrape based on that. But what that doesn't give you is like information about images on the page, right? Like there's no way to view the images. And in this example, like the titles of the books and the author names are like in the images. The model actually has to like look at information in the image and not just the caption. To give you the response. So I think there's like an interesting like thing to build here, or like a new web scraper using like a vision language model.
I don't know to what extent like OCR would be sensitive to these different types of fonts, right? Like, so VLM is just naturally able to handle all kinds of fonts, types and sizes. Yeah. Okay.
These are examples of native image output in Gemini 2.0. Gemini 2.0 can now natively generate images as part of your conversation. Let's say you want to imagine how it might look to turn this car into a convertible. With today's AI tools, this takes a lot of work. You might have to manually mask out this roof area or write a really complex prompt. We brought this image into AI Studio and sent it to the new experimental Gemini 2.0 Flash model. This is a real-time screen capture, and all the prompts you'll see in this video are things that early testers can now try. And this is the entire prompt we gave it, turn this car into a convertible. And it generated this image. These are examples of native image output in Gemini 2.0. Gemini 2.0 can now natively generate images as part of your conversation. Let's say you want to imagine how it might look to
Yeah.
Oh, you want to-
Do the
Yeah.
talking, I'll do
Yes.
the.
Do you want to do a brief overview of generation?
No, you do it.
Or I can do it. Sure, yeah. So what's cool with